Hi guys, this is Dr. G here, and in this video we will talk about ionic bonds and ionic compounds. So in a previous video I actually gave you a brief introduction to ionic and covalent bonds. So in that lesson we learned that uh, chemical bonds such as ionic and covalent bonds are formed when atoms lose, gain or share electrons, right? So when atoms lose or share electrons, you form chemical bonds, and this formation of chemical bonds help the atoms to obtain the noble gas configuration, which is a very stable configuration that atoms can achieve by pairing all the valence electrons. So in that video we also discussed the differences and similarities between ionic and covalent bonds, but the primary difference between the ionic and covalent bonds is that in ionic bonds you have the formation of ions through complete electron transfer. Okay, because of the complete electron transfer between two different atoms, you have ion formations, and there are two types of ions, cations and anions. Cations are positively charged, anions are negatively charged, and of course cations are usually metals and anions are usually formed from non-metals. In comparison, covalent bonds do not form ions and they only share electrons. And the atoms that you will find in covalent bonds are usually non-metals. So that is what we discussed in a previous video. So if you are not clear about certain things, I would highly recommend you to go back and revisit that previous video. But today we are going to specifically talk about ionic compounds or ionic bonds. So as I mentioned earlier, ionic compounds contains ions, and those ions are of two kinds. Anions, which are actually negatively charged, they are negatively charged, and then cations, which are positively charged. So ionic compounds are made up of two types of ions called anions and cations. Anions are formed by nonmetals. Anions are formed by nonmetals, and cations are formed by metals. Okay, so usually when nonmetals gain electrons, you form anions. When metals lose electrons, you form cations. So that is what you're going to need to remember. Okay, so anions are formed by nonmetals gaining electrons, and cations are formed by metals losing electrons. So let's talk about this concept in more detail. So positive ions, or in other words cations, are formed by metals losing electrons. So when we talk about metals, they have low ionization energies. Why? Because they are big atoms. Okay, so when the atoms are big or the atomic radius is big, the atoms have a lower control over its electron cloud, so therefore it is easy to lose electrons from the valence band. Okay, so these loose electrons uh, will help the atoms reach the noble gas configuration. So as an example, I have a sodium atom in this figure. So sodium atom is in group 1a. Okay, so sodium atom is in group 1a, and also because sodium atom is in group 1a, you know that it has only one valence electron. Right? How do you know that? Because for representative elements where the group number has letter A after the group number, okay, the group number is equal to the number of valence electrons. So sodium is a representative element because you have letter A next to the group number, and then the group number is going to be equal to the number of valence electrons. So if you want to achieve the noble gas configuration, you have two options. You can either get 7 more electrons and achieve the electron octet, or you can lose one electron that you have in the valence band and then achieve the noble gas configuration. So which one is easy? Gaining 7 electrons or losing one electron? Of course, losing one electron is much more easier than gaining 7 more electrons. So sodium will easily lose this electron, and once you lose an electron, you have 10 electrons, because originally you had 11 electrons, and then you still have 11 protons. Okay, so sodium has the atomic number 11. Sodium atomic number is 11, and then that means you have 10 protons and 10 electrons, but you already removed the valence electrons, so you only have 10 electrons and 11 protons. So you have 11 positive charges and then 10 negative charges. So minus 10 plus 11, the total charge will be what? Plus 1. So sodium, once it loses its valence electron, it will be plus 1 in charge. Or in other words, you can understand the charge like this. Okay, for neutral atoms, the number of electrons is equal to the number of protons, right? For neutral atoms, the number of protons is equal to the number of electrons. That is why they are neutral. So the negative charges and positive charges balance each other, right? So once you lose an electron, you have one proton in excess. When you have one proton in excess, your charge will be a plus 1. So sodium will lose an electron and become a plus 1 charge, or a cation with a plus 1 charge. Let's talk about anions. Anions are actually negative ions. Anions are negative ions and formed by nonmetals. Anions are formed by nonmetals. So nonmetals, the thing about nonmetals is that they are smaller atoms. Nonmetals are smaller atoms, so therefore it is very hard to remove electrons from them. And they have a very good control over its electron cloud. So they are greedy and very hard to remove an electron from. But it is easy for them to gain an electron. So nonmetals will easily gain an electron and then try to achieve the noble gas configuration. So as an example, let's talk about chlorine. So chlorine is in group number 7A. And the atomic number is 17. Okay, atomic number is 17. Okay, so since for chlorine group number is 7A, you know that chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Okay, so chlorine has 7 valence electrons. Why? Because it is in group number 7A. Alright, so in order to achieve the noble gas configuration, chlorine has two options. You can either lose all these 7 electrons and then reach the noble gas configuration, or you can pair up the unpaired electrons. If you can find another electron, or if you can gain one more electron, you can easily pair up all electrons, and then you will also achieve the electron octet, and that means you have the noble gas configuration, right? So of course the easier process for chlorine is to find or gain one more electron so that it can reach the noble gas configuration. So when that happens, chlorine already had 17 electrons. Okay, you are gaining one more electron, so you have 18 electrons in total. But you only have 17 protons. Nothing happens to the protons, right? So you have 17 protons, which is plus 17 in charge. 18 electrons, which is minus 18 in charge. So the difference is what? The sum of charges will be a minus 1. So therefore, once chlorine gains an electron, the chlorine will become a minus 1 charge. Which is an anion. Okay, or you can understand it like that, like this. So chlorine already has 7 valence electrons. So in order to achieve an electron octet, chlorine will gain one more electron. So you are getting one extra negative particle in one electron. So you have one electron in excess as compared to the number of protons. So if you have one electron in excess, your charge will be minus 1. minus 1. So chlorine will form an anion with the chemical formula Cl minus. Cl minus. So let's talk about another example. Okay, so let's talk about another example. Let's talk about calcium. Calcium. So calcium is in group 2A. Calcium is in group 2A. Okay, that means we know that it has 2 valence electrons. Okay, we know that it has 2 valence electrons because the number of valence electrons is equal to the group number. Okay, and also calcium has 20 total electrons. Calcium has 20 total electrons because the atomic number is 20. So calcium has 20 electrons and 20 protons. So those are the details that we can get from the periodic table. Okay, so if calcium wants to achieve the noble gas configuration or the electron octet, it has two options. It can kick out these 2 valence electrons and then it will reach the noble gas configuration of argon, which is 18 electrons. Okay, so if you remove 2 electrons, okay, if you lose 2 electrons, then you can achieve the electron configuration of argon. Or the other option is actually to gain 6 more electrons and then achieve the noble gas configuration of krypton with 36 electrons. Okay, so these are the two options that calcium has. But of course, gaining 6 electrons is 3 times harder than losing 2 electrons, right? So therefore, calcium will lose the 2 valence electrons and then it will form a 2 plus charge. You are losing 2 electrons, 2 negative particles, so you have 2 protons in excess. So your charge will be a 2 plus. Your charge will be a 2 plus. Or in other words, you initially had 20 electrons and 20 protons, but now you only have 18 electrons after losing 2 electrons. So you calculate the overall charge. You have a minus 18 from electrons plus 20 from protons. So the overall charge will be a plus 2. So calcium will have a plus 2 charge. All right. So that is an example for calcium. So let's talk about oxygen. Oxygen is in group 6A. Oxygen is in group 6A, which means oxygen has 6 valence electrons. 1, 2, 3, 4, 5 and 6. So as you can see, it needs 2 more electrons to achieve the noble gas configuration. Okay, so if oxygen can find 2 more electrons, if it gains 2 electrons, then it will achieve the noble gas configuration of neon. Okay, oxygen of course has 8 electrons. So if you gain 2 more electrons, you will achieve the noble gas configuration of neon, which is much more easier than losing all 6 valence electrons to get to the helium configuration. So oxygen will gain 2 electrons and achieve the noble gas configuration of neon. So if you are gaining 2 electrons, you will have 2 electrons in excess. So that is a 2 minus charge. Or in other words, for oxygen atom, you had 8 electrons and 8 protons in the beginning. If you gain 2 more electrons, then the total of electrons will be 10 electrons. Okay, which is basically minus 10 charge from electrons and plus 8 from protons. So the sum will be what? Minus 2 sum. So that is how you get the minus 2 charge. All right, so I hope that you are very comfortable in figuring out the ionic charges now. So let's move on with the discussion of ionic compounds. Alright, so now I want you to pause the video and see if you could write the formula and symbol of an ion with 16 protons and 18 electrons. So please pause the video and see if you could do this sample question. Alright, so in this question, it says that you have 16 protons and 18 electrons. So this is definitely an ion, okay? This is definitely an ion. How do you know that? Because your number of protons is not equal to the number of electrons, right? So your number of protons is not equal to the number of electrons, so this is definitely not an atom. All right, so this is an ion, we know that. And in an ion, the subatomic particles that will not change are protons, right? Okay, so you have 16 protons, so the atomic number is 16. So you look at the periodic table and then you realize that okay, the atomic number for whatever the atom is 16, and then that atom should be what? That atom should be sulfur. All right, so we are talking about sulfur. And then when you take a look at the number of electrons, you have two extra electrons as compared to protons, right? So if you have two extra negative charges, the charge will be -2. Okay, so if you don't understand what I did just now, so just count the charges. So you have 16 protons, which means it is plus 16, and then you have 18 electrons, which means it is -18. When you add these two up, the total charge will be -2. Okay, so your ion in this sample question is sulfide. Okay, S2 minus, S2 minus. So in this next part of the video, we are going to talk about the common cations and anions that you will find in the ionic compounds. So let's start with the representative elements. So group 1A is a group with representative elements, and then in group 1A you have metals. Okay, you have metals, and then those metals are lithium, sodium, potassium, rubidium, cesium are the most common metals that you will find in the group 1A, right? So in group 1A, according to the group number, how many valence electrons do you have? According to the group number, you have one valence electron. Okay, one valence electron, right? So if you have one valence electron, then you will remove that valence electron to achieve the noble gas configuration. Okay, so if you are removing that one electron, then you will be positively charged. So therefore, all the metals in group 1A will have a positive charge. Similarly, in group 2A, okay, you have two valence electrons. Which means in order to achieve the noble gas configuration, you will remove those two electrons. So if you remove two electrons, they will have a +2 charge. So metals like beryllium, magnesium, calcium, strontium and barium, okay, they will always have a +2 charge. Why? Because they are removing two electrons from the valence band. And then in group 3A, the common metal that we have is aluminium. Okay, so let's talk about aluminium. That is the most common metal in group 3A. And aluminium has 3 valence electrons, which is equal to the group number. And then once you remove 3 valence electrons, you will be a +3 charge. So these are the most common cations that you will find in the periodic table, especially in group 1A, group 2A, and group 3A. All right. So next, let's talk about the anions. All right. So the non-metals are commonly found in group 4A, 5A, 6A, and 7A. Okay. Group 4A, 5A, 6A, and 7A is where you can find most of your non-metals. But carbon is a little bit tricky. Why? Because carbon is in group 4A. Okay, carbon is in group 4A and it has 4 valence electrons. So in order to achieve the noble gas configuration, or 8 electrons, you can either gain 4 or lose 4, right? So carbon can either gain 4 or lose 4 in order to achieve the noble gas configuration. So carbon actually most of the time share electrons. Why do you have to gain or lose all 4 electrons when you have the chance to share, right? So carbon is mostly present in covalent compounds. So carbon is a tricky atom, so it will not be very common in ionic compounds. But group 5A non-metals are the common non-metals are nitrogen and phosphorus. Okay, so in group 5A you have 5 valence electrons. Which means to get to 8, you need only 3 more electrons, right? So both nitrogen and phosphorus will try to get 3 more electrons, and if they get 3 more electrons, they will be minus 3 charged. Okay, their charge will be a negative 3. So this will be the charge. All right, and then for group 6, okay, for group 6, the most common nonmetals are oxygen, sulfur, and silurium. Oxygen, sulfur, and silurium. So these three atoms are in group number 6A, which means you have 6 valence electrons. So in order to get to 8 electrons, which is the noble gas configuration, you will need to get 2 more electrons. So if you get 2 more electrons, the charge will be a 2 minus. So oxygen, sulfur, and silurium will typically make anions with minus 2 charge. And let's talk about group 7A next. In group 7A, you have fluorine, chlorine, bromine, and iodine as the nonmetals. And these nonmetals have 7 valence electrons in the valence band. 7 valence electrons in the valence band. Of course, in order to get to 8 valence electrons, you need to add 1 extra electron. So each of these nonmetals will gain 1 extra electron and becomes a minus 1 charge. So these are the most common anions and cations you can find in the periodic table, especially under representative elements. Okay, so here is the thing. You already know the charge of these anions and cations by looking at the group number, right? So by looking at the group number, you already know the charge of these metals and cations and anions. So therefore, you have to do one of the two things. Either you memorize all these charges, or you will figure it out from the group number. Okay, so based on the element, I want you to figure out the charge, or I want you to memorize the charge. Okay, because no one will tell you the charge of these metal cations or non-metal anions. And this slide actually lists all the common metal cations and non-metal anions, and also it basically shows you the noble gas configuration each of these anions or cations will reach by losing or gaining electrons. Okay, so as you can see, anions will always gain electrons and then get to the noble gas configuration, that is to their right hand side, and cations or metal atoms will always lose electrons and get to the noble gas configuration, which is next to their right hand side. Okay, and also let's talk about the names of these common ions. Okay, so if it is a cation, the name of the cation is the same as the name of the element. Okay, so the cation name is the same as the name of the element, and anion name is a little bit different. Okay, anion name is a little bit different. So when naming anions, you basically take the first few syllables. Okay, you take the first few syllables of the element name, and then you will add "ide" to the end. Okay, "ide" to the end. So for nitrogen, you will take the first few syllables. And then put "ide" at the end. So you do it usually the way your tongue rolls. Okay, so you don't have to like specially try to memorize how to do this. I mean, if you take a look at the element and then the anion name, you basically go with your tongue. Okay, so nitrogen will be nitride, phosphorus anion will be phosphide, oxygen anion oxide, sulfide, fluoride, chloride, bromide, and iodide. Okay, so that is how you name it. You take the first few syllables of the element name and you put "ide" at the end to get to the name of the common anion names. All right, let's see if you could use what we have just learned. Okay, so I want you to pause the video and try to do this sample problem 6.2. Okay, I want you to pause the video and see if you could do it. And this sample problem is about aluminium and oxygen. Okay, so first I want you to identify it as a metal or a non-metal. Okay, so aluminium is a metal, oxygen is a non-metal, right? Which means aluminium should an make a cation. Okay, aluminium should make a cation, and oxygen should make an anion. Okay, and the number of valence electrons, aluminium is in group number 3a, aluminium is in group number 3a, so it will lose 3 valence electrons and form a 3 plus. Oxygen is in group number 6a, which means it has 6 valence electrons, so it will gain 2 more electrons, so you have 2 electrons in extra, so it will be a 2 minus charge. Okay, so those are the cations and anions these two will form. Okay, and then the symbols are also given. The name, so aluminium 3 plus will have the name aluminium because cations has the same exact name as the element, so this will be aluminium. Oxygen anion will have the first few syllables from the oxygen name, and then you put ide, so this will be oxide. Okay, oxide. So this is how you do it, okay. All right, so here is your official answer. And then what are the symbols for ions formed by potassium and sulfur? Let's quickly do that. Potassium is in group 1a, okay, which means it has only one valence electron, so it will lose it to achieve the noble gas configuration, which is K plus, potassium ion. Okay, and then for sulfur, it is in group number 6a. It has 6 valence electrons, so it needs 2 more electrons to get to the noble gas configuration, so it will be 2 minus. Okay, and the name will be sulfide. Okay, this will be sulfide. Okay, you take the first few syllables of the name and then put ide at the end. So with that, I'm going to conclude this lecture video because it is already getting too long. Okay, so this will be the part 1 of ionic compounds, and in the next video I will talk about specifically writing formulas for ionic compounds. Okay, writing formulas for ionic compounds. All right guys, let me know if you have any questions. You guys have a good one. Take care.